So in this particular lesson, we are going to look at SNI, and then we are going to look at Fiddler, a packet capturing tool, just like Wireshark, but in the case of HTTP and HTTPS. And we will see how to decrypt HTTPS traffic using Fiddler. Before that, we'll get into the topic of SNI, or Server Name Indicator. SNI, SAN, CNAME, all these things are connected via DNS. So we need to discuss all these three things, including related concepts around DNS. And then we'll look into the Fiddler traffic. Server name indicator, and we talked about CNAME or common name, which is one of the main things in the certificate. And then we talked about SAN or subject alternate names. So these are two things in the certificate, and this is given by the protocol. In fact, all these three things are one and the same thing. We are going to understand a little more about these things and how these different names with slightly different use cases gel together. So this is server name indicator, and this is common name and subject alternate name. At times this is also called subject or subject name. In fact, all these three used in slightly different naming conventions at different places. Sometimes it is used as FQDN host name, certificate name, different names are there. Normally, the whole thing I refer to SNI or server name indicator, because that is the main string which we need to verify. And that's what we are going to look at here. To start our discussion, we need to understand how the protocol works, what the client is giving to the server and what the server is giving to the client. For that, we need to resort to a Wireshark trace. There are other ways to do it. In fact, the OpenSSL s_client is pretty useful, as well as curl is pretty useful. But let's get to a little more lower level and see what comes into the wire when there is an SSL handshake. That's what we are going to do here to understand more about these different entities right there in the screen right now. So from the last session, we have reverted a few things. Let's see everything is working as expected. So we are not expecting this to be working because we have removed that particular CNAME or the entry from the host file. So I'm going to type localhost :443 and it is working. Again, not secure because it is not giving the correct certificate. Just like before, it is giving this particular certificate right here. Now this is kind of good enough. What we can do is that we can filter the traffic for localhost and see what are the packets coming through while we are refreshing the page. So I'm going to start Wireshark. So if you are new to Wireshark, I really recommend my previous networking training. Everything is there. It is a packet capturing tool. It captures the packet at the physical layer of the network. There is an update available, but I'm going to ignore it for the time being. So what I'm interested is my loopback adapter. This is the adapter I'm interested in, the loopback adapter, because that is used for the local communication like localhost. So I have started a capture on the loopback adapter. There's no traffic in the loopback right now. What I'm going to do is I'm going to refresh this particular page. We do have some traffic coming in. So this SNI is localhost. Looks like this is the connection we are looking. So what I'm going to do is I'm going to put a filter. So if you have any doubts, like I mentioned, we have a detailed training explaining this particular thing we are looking at. So this is the TCP handshake you're looking at before encryption or before any TLS packets. SYNAC ACK. Here is what client hello, the first TLS packet, which is on top of the TCP. In fact, TLS works on a lot of other protocols. Pretty much it can work on any kind of transport, but normally it is TCP. So let's see what is the content of the packet. This packet is not encrypted. As you can see here, the client is giving a lot of things to the server inside the client hello. So there's a list of cipher suites it supports. It is giving to the server. These are the different cipher suites the client can support. And the supported version of TLS, it supports two versions of TLS, 1.3 and 1.2. And what we are interested is there is this thing right here, server name indication. And inside that, there is something called server name, which is localhost. So this is a string which is given from the client to the server. Very important. Probably one of the most important information other than the cipher suits and things like that. So what server should do is server has to give a certificate which the client is trusting with this particular string in the subject or in the subject alternate names. Let me repeat that statement once again. Client is giving this particular packet. This is a client hello packet we are looking at. This is what is going inside the wire. This capture is from the physical layer of the network. Don't forget that. This is what Eve sees. Eve can see. The whole world can see what we are seeing. Now, what is the client asking? The client is asking, I need a certificate with this particular SNI in the subject or in the subject alternate names. That is the importance of this particular string right here. There are ways this can be modified using curl command and things like that. We'll use the browser itself to modify this particular string right here. I'll show you how to do it. But the client is asking certificate for this particular string right here. That is the important part here. Now, the server has the responsibility to give a certificate as a response. What is the main criteria for the certificate? The certificate should be trusted by the client. It should be trusted by one of the CAs right here in the certificate trust root. It should be signed by one of these CA certificates. And the subject name should have this particular string right here. Those are the main criteria client wants. Now, what the server is saying, server is giving a series of packets back to the client. The main information we are getting from the server is the server hello. Server has selected the protocol and things like that. And on top of that, server will be giving a certificate. So the handshake protocol is server hello, and there is a session ID and things like that is being determined, and cipher suit, which the server has selected. Along with that, server is sending some encrypted messages along with the other information. But the main thing we would like to focus is the SNI, which is given by the client. Now what we can do is we can change this SNI to something else, and we will see how it is getting changed when the DNS resolution is modified. So we are going to the same file, the host file, and I'm going to add, this is for test SNI 1234, and we are going to put that for a local host. So I have added a random entry inside the host file. You can think of it like a DNS entry here, just like we did before. Basically, someone asks for this particular host name, it will resolve into this IP address. All the details are there in the networking training if you're interested. I have saved the file, and I'm going to change the local host to this particular piece right here. And we are going to restart the capture, continue without saving, and we need to remove this particular filter we have put, and going to refresh it. Again, the connection is not private, advanced, continue, so that we will get the page. Now I'm going to stop the traffic. Let's have a quick look if we have an SNI with that particular name within the trace. So the SNI here is a local host. Again, local host. I'm expecting the new SNI. As you can see, it is right here, the client hello. Let's filter it with a stream, follow TCP stream, and client is saying the hello, client hello with this new SNI, and server hello with all the certificate and things like that. The key exchange hello done, and a lot more other information we are getting from the server. And from here on, it is moving to completely encrypted traffic. It is using Diffie-Hellman for the key exchange, as you can see here in the packet. Now to see what is the certificate coming from the server, it is this particular C name, and it doesn't have any subject alternate names. So this certificate is not going to work because the SNI is this particular string right here, which is converted to the corresponding IP address using the DNS resolution. So this is equivalent to the DNS resolution, and this is how the SNI is given by the client. So SNI is one of the most important fields inside the client hello packet. So the client gives the SNI to the server. Now the server gives back the certificate with this particular SNI, and the client verifies. What is the client verifying? Client verifying whether this particular SNI, which it has asked the server to give, whether the certificate has that SNI in the CNAME or in the SAN, and making sure that it is properly validated and signed by a proper trusted CA. So very important to understand the role of SNI, CNAME and SAN. Don't get confused. There are a lot more names used for these things, so it is easy to get confused. So let's make sure that we understand the use of these strings, which is what the certificate is all about at the end of the day. Verifying these three things. So CNAME and SAN given by the server, and this is what the client wants. And this is connected to the DNS like we've seen. The DNS has to resolve this particular string to an IP address. Then going to that IP address, you get this particular certificate with CN and SAN. So next, what I would like to explain is the way certain proxies work. HTTP proxies, antivirus proxies scan network traffic in corporate environment. That is what some of these proxies and firewalls does. How they work in the encrypted world, how they decrypt the traffic, and how they manage certain things. Let's assume this is google.com right here out in the internet. So this is google.com and the internet, the public internet. Google is connected to the internet, and there is a secure corporate environment right here. So this is the company network. There's a company network in which company wants to look into every single traffic the employees give and take from the internet. These are the company employees sitting inside a company office. These are all different employees sitting there. Now company wants to monitor all the traffic they are sending to the internet, which includes the Gmail and all the SSL traffic. Now this is Alice and this is Google. Now Alice is trying to connect to the internet. So once the traffic is encrypted, so this is Alice PC right here. Let me draw that in a different color. So this is Alice PC or Mac or whatever operating system she uses, but this is what she's using right now. Once the traffic goes out of the process boundary of this particular PC, it is completely encrypted. That's what we've been discussing throughout this training so far. Now the administrator here, this is the administrator of firm XYZ. This is firm XYZ. And this guy right here with the hat, he's the admin of the XYZ organization. He's the administrator. He wants to know what Alice is sending out. He cannot see anything if Alice is using SSL. One thing he can do is to block everything, block google.com, block every internet traffic from Alice so that she won't send any proprietary information out or download any kind of proprietary information from somewhere. But that is very restrictive. He don't want to do that. Now the question is how he is going to monitor what Alice is sending, because she is using encryption. The common way it is done is having a proxy right here. We talked about proxies a lot in the previous training, the networking training. But in this case, we are going to discuss the SSL part of the proxy as well. So the google.com certificate, is signed by one of the trusted CAs. Now, when Alice connects to google.com, she has to go through this internet proxy. So this is how her connection goes. Otherwise, she cannot go out of this particular network boundary. She has to go through this proxy. So one of the things which this proxy does is the proxy terminates the SSL. So there is something called SSL termination. It is a fancy word for decrypting the traffic. A lot of people uses that term when they talk about corporate networks and things like that. SSL termination. Don't get afraid. It is a fancy word for decrypting the traffic. Your session key is terminated. Your SSL session is terminated. Your traffic has been decrypted by someone. No longer your session key is used. There could be a different session key, but that is after decrypting the traffic. Remember, your symmetric encryption session key is everything once the SSL connection is started or the TLS connection is started. So that is getting decrypted right here. And it decrypts the traffic. For example, Alice is sending her password, Gmail password. She is accessing her Gmail, alice@gmail.com. She has typed her password and that password is decrypted right here in plain text. And then whatever tool Mr. Admin here want to check, he'll check using that tool. And if everything is okay, he will send that exact information to google.com. And whatever google.com comes back, say for example, the login page, login succeeded, it'll give to Alice. Now the question is, you must be asking, if this can be done, it's a typical man-in-the-middle attack, how this is going to work. The trick here is, the certificate Alice is seeing from google.com is not really from google.com. But this particular proxy here, the proxy will terminate the SSL here and re-encrypt the traffic with its own CA, which is present in Alice trust store. Very important thing to understand. Pretty much something like we have done in the previous lesson. It creates a fake google.com. When Alice tries to access it, it gives that particular google.com certificate, and Alice browser trusts that certificate because it is there. That particular root is there in the trust store of the Alice. Now the actual google.com certificate, again, that SSL is also terminated here. So let me draw the decryption point in a different color, say white. So this is one of the decryption point where it decrypts the traffic from google.com, and this is another endpoint where we decrypt the traffic from the PC of Alice. Whatever this thing says, this PC trust, because there is a special proxy related trust certificate, CA certificate, there in the trust store of Alice computer. And that is also managed by this guy, normally using some kind of group policy, GPO, in the Active Directory, pushes all these trust certificates to different computers of all the employees. So this is where the traffic is in plain text, and whatever security software is there, it analyzes it and give it back. Google is thinking that it is talking to this particular proxy. It cannot even see Alice, and Google is getting everything it wants because this proxy is behaving just like a client. Google has no way to find it out that it is not talking to Alice. All the username, password, everything is being transmitted back and forth after terminating the SSL. Now, this is a technique which is used in almost all the banks. If a bank is not using this particular technique to connect to internet, in Australia or probably even in India or US, it may not be compliant with the rules of the country. So it has to analyze the traffic employees sending to the internet. In Australia, all the banks I know does this. Almost all the financial institutions in Australia does this using a internet proxy. That doesn't mean that someone is looking into your password or Gmail account or anything like that, but the traffic is decrypted within the proxy and being checked before you send it to the internet. So this is a mechanism within the law to spoof into the SSL traffic. It is not any kind of hacking or any kind of demerits of SSL, because everything needs to have this particular trust certificate, the CA certificate, the extra CA certificate present within the trust store of these employees, which is to be controlled by this particular guy right here. If you bought a new laptop, this will not work because it doesn't have that trust certificate. Now, we are going to see this particular mechanism using a tool called Fiddler. So Fiddler does exactly the same thing what we just discussed here. So Fiddler decrypt the traffic and allow us to look into SSL traffic and re-encrypt so that the browser will trust the connection. So let's install Fiddler and have a look to understand more about this. So I just typed install Fiddler in Google. I'm going to the first link. Let's see. So download for Windows. You can type all the things here. I think I have already downloaded. So once you have downloaded, you should see something like this. I'm going to double click on it. I'm going to agree. So this place it is going to install tool. So I'm installing Fiddler. Installation was successful and I'm starting Fiddler. Now let's start Chrome and try google.com. Fiddler is looking to be active. So I'm just cleaning the list a little bit and going to the browser and putting some traffic into it. So I'm going to google.com. So Google has loaded. As you can see, looks like it has captured the data. It is saying HTTP decryption is disabled. Click here to configure. So I'm going to do that. And I'm going to click on this button. And here is the main thing. Let's read it carefully. Scary text ahead. Read carefully. That's exactly what we are going to do. To intercept the HTTPS traffic, Fiddler Classic generates a unique root certificate. This is a root certificate we've been talking about from the proxy. Fiddler is nothing but a proxy. You may configure Windows to trust this root certificate to suppress security warnings. This is generally safe. Click yes to configure trusted CL list. No if it is all geek to you. So what they're saying is that I'm going to add a trust root certificate to your trust store. If you know exactly what this means, you can click no and play with it, but otherwise you go ahead and add that thing. So we are going to click yes, although we know what it's going to do, and we're getting warning. You're about to install a certificate from the authority claiming to represent do not trust Fiddler root, and share thumbprint and all the details right here. Do you want to install this certificate? This is from the Windows. We are getting this particular warning because it has called an API, Windows API, to install the certificate. I'm going to click yes. Again, it is adding more check, giving me the CNAME itself, because it is a very critical thing we are adding. If this certificate is bad, it can compromise the entire system. Again, yes, and it gone to elevation and it is added. Now let's go ahead and see the trust root. So let me refresh this. So this is our trust root. So as you can see here in the trusted root certificate authority, the root has come up. This is the Fiddler root we have just added. Now what we are going to do is we are going to decrypt all the traffic. The Fiddler is going to decrypt all the traffic and re-encrypt the traffic, just like we discussed in the earlier Blackboard session. So I'm going to refresh this particular page right here and coming back to Fiddler. So in here we have check for revocation, all this ignore server certificate error, all that kind of things are there. Extra configuration from all processes. It is going to decrypt traffic from all processes, not just the browsers. Certificate generated by cert enroll engine, pretty much the same OpenSSL command. It must be executing behind the scenes. Couple of details. If you want to skip the decryption, it is right here, but I'm going to click OK to this. Again, what I'm going to do is I'm going to clean, remove all, and I'm going to refresh the page, the google.com page. Let's see if you're able to decrypt the traffic using Fiddler. I think there is a page is cached. If the page is cached, one of the things you can do is start the developer tools and empty cache and hard reload. If you right click on this refresh button, you will get empty cache and hard reload like this. It is actually a feature in Chrome. Most of the browsers support. Edge is Chrome. As a matter of fact, we are using Edge, not Chrome, although I think I said Chrome. We are not using Chrome. So we have the traffic from Google in the Fiddler. It is HTTPS traffic. The host is google.com and it is getting some kind of data right here, and it's kind of the size of the body. And Microsoft Edge, that is the browser we've been using, and it is the process ID of the process which is communicating. And this is a detail about the packet. It is saying the response body is encoded. Click to decode. So we are decoding and we are getting this data right here. Some kind of JavaScript code which it is decrypting right here. So this is the man in the middle, this particular Fiddler traffic decryption we are seeing. We are decrypting an SSL traffic within an SSL connection. This could be our password sitting here, cookies. You're looking at some sensitive information decrypted. Now how that is done, let's have a look. So if you go back to Google right here, this is a page we've been loading. And if you go to the certificate, the connection is secure, which is good. The connection is secure. Now, if you click and look at the certificate, you can see the organization is not Google. It is Do Not Trust, created by Fiddler2.com, issued by, very important, issued by Do Not Trust Fiddler root, as you can see here. And if you look at the details, the certificate chain has been changed. It is different. Now, from where this certificate is coming from? To understand that, we need to click at something called proxy setting. So if you go to the settings, we'll click on proxy, open your computer's proxy setting, use a proxy server on. Use a proxy server is on. Edit, and here we go. We have something listening on this particular port right here. On port 888 4 8s are there. Now, who is there in that port? We need to understand. So this is where your knowledge of networking comes into the picture, and I really recommend you watch the networking training. Unfortunately, I cannot give you any other materials because that training is kind of a unique training which I have done, the networking training. You can read about HTTP proxy if you don't want to watch that training, but to get the complete picture of what we are doing here, you need to watch that training. So basically, the Fiddler is acting like a proxy, and it is listening on port 888 or 8888. Now, how do we verify that? If you remember from the previous training, it is the netstat command, or we can use the resource monitor. I'm going to use the resource monitor in Windows, or you can use netstat command if you're in Linux. And if I go to this particular port right here, 8888 fiddler.exe, you can see it is listening on this particular port as a proxy. Very important to understand what's happening. This is not some kind of toy stuff we are doing. Every single financial institution do exactly the same thing. Very important to understand this particular fact, what we are discussing here. Every single bank, all the 4 major banks here, I know for a fact uses this particular technique here in Australia. I'm pretty sure the other banks does as well. So this is how they decrypt the traffic and understand what each and every packet going out of the network and making sure that it is the right packet. Hospitals, financial institutions, pretty much everyone uses a proxy just for this purpose. Now let's draw the diagram of what's happening, how this particular decryption is happening. This is an SSL traffic we are decrypting here. Pretty much the same diagram we have seen before. We'll redraw that diagram in the context of Fiddler. We'll have a more concrete diagram in this case. So this is the same diagram we are going to draw, but in a bit more concrete way. So again, we are going to have the google.com. So this is our google.com right here. It is having its own IP address and things like that. Now this is google.com. And google.com, as before, it is connected to the internet. This blue is the internet, blue cloud kind of thing I'm drawing. That's the internet, or the public network, whatever you want to call it. So that is the Google. And Google is connected to the public network. And let's say the IP address of Google is 1.2.3.4. Let's assume this is the IP address. This is the public IP address of google.com, right? Now, this is my laptop sitting right here. So this is my laptop, and within that laptop, we will have Fiddler running. So this is the Fiddler running. Then this is my Edge running. So this is Fiddler, this is Edge. Just like any other browser, Edge is an HTTP client. This is an HTTP client. HTTP client. So HTTP client has something called HTTP proxy. Basically, it is a proxy for both HTTP and HTTPS servers. Now, the idea here is that if there is no proxy, Edge will connect directly to Google through the internet. So Edge will be seeing the IP address 1.2.3.4 and start communicating with that IP address. I'm trying to avoid all kind of extra things like the router which I am connected to and my local network and all that details. If you want such details, like I mentioned, visit my networking training. It's really explaining those kind of internal details. But in the current scenario, you can assume that it is connected directly to the Google and get the package, and there is no decryption. There is no man-in-the-middle attack. Now, that is not the scenario here. That was the scenario before we install Fiddler. Now, once we install Fiddler, this is a guy. Let's draw that in a different color. So once the Fiddler is in place, so this is a Fiddler. Fiddler tells the operating system that I'm going to behave like a global HTTP proxy in the whole system. That is a setting we have seen, that manual proxy setting. And I'm going to listen on port 88848. Now what will happen is every single HTTP client, Edge for example, will connect to this particular port right here to make any kind of communication to the internet. It'll go to this particular port, and then this guy connects to the internet. So the connection goes through this proxy right here, and the proxy will further connects back to the HTTP client, in this case, the Edge. And in this case, it has installed, we have seen that it has installed the trust certificate. So let's draw that in a different color again. This is the trust store, and there is this do not trust Fiddler certificate in our trust store. We have seen that. And that is what making Edge to believe whatever is giving, whatever traffic coming from Fiddler is to be trusted. Pretty much the same thing we have done in the previous lesson. So Fiddler is decrypting this traffic. These are the decryption points. If you look at, and then this is another decryption point, just like the proxy example we have seen before. And here we can see all that packets decrypted, all that encrypted Google communication. For example, the Google password. If you're typing the password, that password will come here. Cookies, passwords, pretty much you can read anything and everything here once the communication is decrypted. So in this case, Edge will connect to port 8888, and then Fiddler will connect to Google, and vice versa. The communication comes back. Let's see that traffic. So the best tool to see it working live is something like Wireshark or Process Monitor, but it's very difficult to filter. Let's try it with Resource Monitor, and we'll see if that is possible. So in this case, you can see that the Fiddler is connecting to a remote address. These are the TCP connections available in the system right now. So it is connecting to a remote address right here. So one of the things which I have not explained in the picture is the DNS resolution while a proxy is present. So let me go to that as well. So when someone types google.com, when the proxy is present, when Fiddler is present in this case, when someone types google.com right here, because there is no routable traffic, the DNS resolution also go into the proxy. It is the proxy which is going to resolve that particular name for this edge. So there is no business of Edge connecting to 1.2.3.4. It can't even see this particular IP address when the proxy is present. Edge will see only the IP address of this particular proxy. So we'll see that in the networking console, in the resource monitor. So what I'm going to do is that I'm going to refresh some of this page so that there will be some kind of traffic generated. So we'll go to developer tools. You can press F12, open dev tools. Why I have open dev tools is just I want to empty cache and hard refresh so that the pages will get loaded, so that we will see some traffic. As you can see, there is connections from Fiddler. Let's see some edge connections. As you can see, Firefox is there. Firefox has connected to loopback. So it is a loopback connection to this particular port. So Firefox has not connected to the internet, as you can see. So let's sort it with the process name right here. So the Firefox is connecting to this particular port number. Same with MS Edge. It is also connecting to this particular port because that's where the proxy is listening to. It is also connecting to a local port 9229. Doesn't matter to us. Another thing matters to us is that it's not connecting to much of outside network. So it is completely connecting to inside. So when we shut down the proxy or the Fiddler, this thing will change. We'll see that as well. But right now, most of the connections are going to this particular port right here. If you want, you can capture a Wireshark trace or Procmon trace and you can see everything in a real-time action. But right now, we are just getting a feel of it. This is more than enough. So now what I'm going to do is that I'm going to just close it so that things will get reverted. Let's see our proxy setting. So proxy server is off. So when you shut down Fiddler, the proxy setting got off. It was on before. Now, if I refresh this particular page, things will be different, completely different. There's no proxy anymore. Let's see, the certificate has changed. Sometimes it'll be using the cached certificate, but it has changed. As you can see here, the CNAME is WR2 Google Trust Services. As you can see, the signature chain has changed. This was do not trust when the Fiddler was running. So no one is there in the middle at the moment. Now if you go to the resource monitor to see the connections, as you can see there is not 888. So that's sorted with Edge. As you can see, so many remote IP addresses are coming up and all connecting to 443. So there is no Fiddler anymore. So it's all direct connections. So the connection is coming from this particular IP address directly to this remote IP address. It was loopback before, but now it has changed to proper IP address. So as of now, the direct routing is happening because the Fiddler has shut down. So to summarize some of the things we have discussed, we have talked about the SNI, CNAME and subject alternate names, and how it is important when it comes to the certificate which is delivered from the server. We have seen that. And we know the importance of trust root and how a trust root can be manipulated by a tool like Fiddler or a proxy. This is a technique which is used pretty much everywhere and giving the feel that the communication is encrypted while there is decryption happening in the background to look into the traffic, just like we did. And we have seen the working of something like a proxy using Fiddler. So to conclude, we have seen Fiddler as well as we have discussed SNI, one of the most important topic when it comes to SSL and TLS. SNI is the one which is getting verified across the certificate. The signature verifies SNI. And we have seen how to decrypt traffic using Fiddler. A very important tool when it comes to HTTP and HTTPS troubleshooting. And we have seen the wider implication of a proxy, how a proxy can decrypt internet traffic, the encrypted traffic, and take something like a password, for example, in plain text. We have seen all these things. Now there are a few more topics in this particular region, so we need to cover that. So let's get to the next chapter.